Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Now, in this video, let us discuss today a number of problems related to preprocessor directives. So, let us start with what do you mean by a preprocessor and what are the available preprocessor directives. So, before any C program is compiled by the program or by the compiler, there is another software called preprocessor which will be doing the required text substitution. So, the source code is processed by the preprocessor before it goes for compilation. Now, the commands which you are using in the preprocessor are called preprocessor directives and they all begin with the symbol hash. So, we can also say C preprocessor is a text substitution tool and it instructs the compiler to do required preprocessing before actual compilation. So, let us see what are the commonly used preprocessor directives in C language. So, we'll start with the first preprocessor directive called hash define, which substitutes a preprocessor macro. So, whenever you want to write a macro, you have to use the preprocessor directive called hash define. Now, there are two types of macros we use in C programming. One is called simple macro and another one is called parameterized macro. So, for both the macro substitution, you have to use the hash define directive. And whenever you are writing a macro, that will be substituted before compilation by the preprocessor. Next one is called hash include. If you want to include any kind of header file or any other kind of file in the program, then hash include directive must be used. So, for including the library files, we use hash include directive. But other than the library files also, if you want to include any file in your program, you have to write hash include that file name. So, it inserts a particular header from another file. Third one is called hash ifdef, undef and endef. So, these are related to conditional compilation like hash if, hash else, hash endif, hash elif. So, these are related to conditional compilation. Hash undef is used to undefine a preprocessor macro. Similarly, hash not defined, ndef, it returns true if a macro is not defined. Hash ifdef will return true if a macro is defined. Similarly, normally if will be used, hash if will be used, it will test a condition whether it is true or not. Similarly, you can write an else part to the if condition and endif is the closing tag if you are using if else. Similarly, elif, if you want to write multiple conditions, then you can write hash elif also. So, hash elif is same as hash else plus if. Similarly, hash error is used to print any error message on the standard error device. And hash pragma is a miscellaneous directive which will issue special commands to the compiler using any standardized method. So, these are the commonly used preprocessor directives we have discussed, and we will discuss what are the types of preprocessor directives used in C language. So, all the preprocessor directives are categorized into four types. One is called the macros, second one is called the header files inclusion, third one is called conditional compilation, and the fourth one is called the other directives or miscellaneous directives. So, hash define is used for defining a macro. So, you have to use hash define for defining any macro. The macros are of two types. One is called simple macro and parameterized macro. Macros with parameters. So, you can say parameterized macros. Next is called header file inclusion. So, if you have to use or include any header file or any other file, you have to use hash include directive, hash include followed by file name. Third one is called conditional compilation. These are set of commands which are included or excluded in source program before compilation with respect to some condition. So, for that you have to, if a macro is defined, you have to write hash ifdef. Similarly, if the closing tag is hash endif. Similarly, if you want to test a condition, then hash if else as if not defined. These are a set of directives or commands used for conditional compilation. And the last one is called the other directives or miscellaneous directives. So we have has pragma directive, has undefined to undefine a macro, and so on. Next, let us understand what is the program process flow. Whenever you write a C program until its execution, what are the processes that is going on inside? Suppose you have written the source code that is called sample.c. Then that source code is first pre-processed by the preprocessor. So this preprocessor will replace any kind of macros available or any kind of conditional compilations or any kind of header file. So it will try to replace the hash defined, any macros are there, or you have included any files, or you have done any conditional compilation, and so on. And it will produce one intermediate format that is called sample.i. And after replacing those macros and other files or conditional compilation, whatever you do by the preprocessor, then we call the source code as expanded source code. Now, once it is expanded source code, then that expanded source code is sent to the compiler. The compiler will produce the intermediate form that is called assembly source code. Then there is an assembler which will produce the object code. So the assembly source code is the intermediate form called sample.s, and that is again converted into sample.o, that is into the object code by the assembler. So the assembler convert the source code into object code here. Now, after that, the linker is another software which will produce the executable code called sample.exe. Now, the linker will convert the object code into executable code and also combines all the object codes together. Then the loader will load the program in CPU, and now the CPU will execute the program. So now it is ready for execution. So these are the flow that happens or that goes on inside whenever you write a .c file, and till its completion or till its execution, there are so many intermediate files that are generated. So the sample.c is first pre-processed and you will get sample.i, and then it is converted into assembly source code, that is sample.s, then it is converted into sample.o and sample.exe. So from sample.c to sample.exe, there are so many steps available. But as an end user, you cannot see all those files. You can see only the object file and the executable file. Sample.o and sample.exe file only you can see it. Now, let us understand a number of programs related to preprocessor directives. So, let us switch into our .c++ compiler and start executing the programs related to preprocessor directives. Now, the first program that we are going to discuss is find the output of the code. So, first of all, write the structure of the C program. So, hash include stdio.h. This is the header file, and this is one of the preprocessor directive. This is the preprocessor directive to include the header file. Then let us define a macro. So hash define square is the name of the macro which takes one parameter called x, and that what is that square of x? Let us define it as x into x. Now let us write down the main function. So hash define is the macro we have written. Then we are writing the main function. So the structure of the main function we have written. Now let us declare one integer variable int I, and that I is equal to 64 divided by square of 4. Now what will be the output of this code? So printf %d, comma the I value. So let us first save the program and let us compile and run it. So here you can see that square of x is defined as x into x. So here whenever the preprocessor will replace the square of 4 with 4 into 4, then what will be the output? So it is 64 divided by 4 into 4. So in this expression, first let me write here, it will be same as writing 64 divided by 4 into 4 will be replaced. Now, how the program will execute this? 64 by 4 into 4. So here division and multiplication both have the same priority. So that's why division will go on first. So 64 by 4 will be taking place. 64 by 4 is 16. So 16 into 4 will be again 64. So the output should come as 64 for this program. Now let us compile and run this program. Now you can see the output of this code is 64. So we have got the output correctly. Now let us move on to the next program. So let me copy paste this or Control N, one new window. Okay. Now hash include, find the output of the code. Hash include stdio.h. Let us write down the structure of the main function. Return 0. Now, after writing this, let us go for the next program using preprocessor directive. Now, let us define a macro or a symbolic constant, we can say, as defined. A is 10. Now, inside the main function, let us write a variable int j, and j is equal to a plus plus. Now, print the value of j. Printf %d, comma j value. And if you will save this program, so let us save it as preprocessor directive second program. Okay, and let us understand. Now here we have defined a simple macro. A is 10. So wherever A appears, that will be replaced. So here this macro is also a symbolic constant. That means wherever A appears, that should be replaced by 10. So A is a symbolic constant over here. So whenever you do A plus plus, that means 10 plus plus, 10 is a constant. So 10 plus plus you cannot do because A is a symbolic constant. So its value cannot be modified. As it is a constant, it cannot be modified. So if you will try to run this, then what will be the output? You can see over here that you are getting the error over here because L value required as the increment operation, because A is a symbolic constant and 10 plus plus cannot be done. So for that you are getting the error over here. So hope you understood this program, that why you will not get the output of this code and why you will get the error. A is a symbolic constant, so constants cannot be modified. Due to that reason, you are not getting the output and you are getting the error as L value required. Now let us go for one more. Let us modify this. Let us modify this program and do in some other way. Now here do some changes. Let us first print the value of A first. Okay. If you will print the value of A, you should get the value as 10. Now, let us define the macro again. Has defined A as 20. And again print the value of A. Then what will be the output? And let us write here, has defined A 30. First save the program. Now let us understand the code first. So here the macro is defined thrice, and in C program that you can define a macro anywhere in the program. Generally it is defined that is at the top before writing the functions, but you can define a macro anywhere. So here we have defined A is 10. Okay. So whenever you will print the value of A, you will get here 10. Now again the same macro name has been defined with a different value. Has defined A is 20. Now when you will display the value of A again, you should get 20. And you can see that third time the A is defined outside the function. and we are not doing any operation on that value. So what will be the output? Let us see it. You can see that both 10 and 20 are combined. So let us give a slash n here so that you can see the output properly. So if you use slash n, so you can see that first time the value of A was 10, then it was modified to 20. So 10 and 20 are the output for this code. Now let us move on to next program. Find the output of the code. Hash include stdio.h. Let us write down the structure of the main program always. Return 0. Let us define a macro, parameterized macro. Let us define as defined multiplication of A comma B. Let us define it as A into B. So for using this parameterized macro, let us define some variables. Integer I is equal to 2, comma, j is equal to 3, comma, k. K is equal to, use the macro, parameterized macro, I, comma, j. Now print the value of k over here. And let us use the same macro again with the different parameters. This time I plus j, comma, I minus j. So same macro we are using, just we are changing the values of the parameters. And let us print the value of k again. Okay. So this is the program. Then what is happening over here? Let us first save the program and try to understand. Now, here I is equal to j is equal to 3. Whenever you are calling the parameterized macro multiplication with ij value, which will be replaced by a into b, that is I into j over here. So which is nothing but 2 into 3, which is nothing but 6. Okay. So k value will be printed as 6. Again, the same macro you are calling with I plus j. So which is I plus j multiplied by I minus j. So a into b. So a is nothing but here I plus j. B is nothing but here I minus j. So I plus j into I minus j is going on here. So here let us replace with the values. So here 2 plus 3 multiplied with 2 minus 3. So if you will see how to evaluate the expression here, you can see that multiplication has got higher priority than plus and minus. So here the expression becomes 2 plus 6 minus 3. So which is equal to 5. So the output for k should be 5. Okay. Now let us run this program and check it. So you can see here, first time k value is 6, second time k value is 5. So we are getting the answer correctly. So this way you can write this program. Now let us understand through another way. Let us copy this program and modify a little bit. Instead of, whenever you are defining this parameterized macro, let me write it as not a into b, but I'll put the parenthesis for a and b. Now what will be the output? So you can see here I value is 2, j value is 3, and we are finding out the k value. So you have to understand that it is I into j. So I and j are in parenthesis. So which is nothing but 2 into 3. So it won't affect much. 2 into 3 is same as 6 only. Okay. So here you will get 6. But in the next case, whenever you are using the same macro again, so I plus j is in parenthesis, which is nothing but a multiplied by b. So here the output will be changing. So I plus j. So what is the value of I plus j here? Is 5 multiplied by minus 1. 2 minus 3 is minus 1, which is equal to minus 5 here. Okay. Now let us save this and run. So it is 5, fifth program, and let us run it. So you can see here, first time the value of k is 6, second time the value of k is -5. So hope you understood the small or minute difference between both the programs. Now let us go for another program. Find the output of the code. Hash include stdio.h. Now let us define a macro as defined square of x. Okay, we have defined a macro square of x here. Now let us write down our main function, return 0. Now use a variable x here int x, and x is equal to 36 divided by square of 6. Okay, square of 6. So here it is a similar program that we discussed. So here we have to define what is that macro. So let us take as x into x. Okay, after that print the value of x. Now what will be the output? So you can understand in the similar way we have discussed earlier one question. So here it is 36 divided by square of x will be replaced by square of 6 is nothing but 6 into 6. So it will be evaluated. 36 by 6 will be evaluated first from, because the associativity is from left to right. 36 by 6 is 6. So 6 into 6 is again 36. So let us save and understand what is the output. So you can see the output as 36 over here. Now let us go for another program. Find the output of the code. Hash include stdio.h. Then let us write hash define scanf. Okay, scanf. Then percentile s hello world. Percentile s hello world. Let us write down the main program structure. Return 0. Now in this program I want to call the macro. So printf scanf, scanf. Then what will be the output of this code? Okay. Now let us save it and let us run this program. Now you can see over here, scanf is defined as percentile s hello world. So here percentile s hello world followed by percentile s hello world will be written. So what is the output that you are going to get? So you can see here percentile s hello world, and for that percentile you will get once more hello world. So this is the output of this code. Now let us move on to the next program. Now find the output of the code. Here suppose instead of defining a macro, if you will write like this, then what will be the output? Suppose Rama percentile s psi we have written, followed by comma Hari we have written. Now what will be the output of this code? Now in this case, in this name psi, percentile s is there. That means s is treated as a control string. Percentile s is treated as a control string. So due to that reason, Rama will be printed as it is. Then percentile s will look for a string. That string is nothing but Hari, and AI in the psi s has gone for control string, then AI. So this is the output of this code. So Rama, Hari, AI. So this way you have to distinguish that what you want to do or how the output will look like. Next, we'll go for the next program. Now, hash include stdio.h. Let us define a macro. Main is nothing but n comma a comma I comma m, which is nothing but m. We are using here the let us define, which is m. We are using here the token pasting operator m a, again token pasting operator, okay, and then n. Let us defining like this. Again write has defined. Let us write here a macro and write main macro use here and n comma a comma I comma m over here, okay, and write your main function printf hello c, okay. Then what will be the output? Now let us write the semicolon over here and return 0. Now can you identify over here that what is going on? We have written a macro NAIM. So it is MA, this is not, this is I and this is M. Okay, let us check it. Yes. So here the name main is a macro here that is constituted by this 4 characters which are pasted together, which makes main here. Okay, so MAIN, here we are using the token pasting operator. So here main is a macro which is replaced. Okay, so that's why it is showing you the output hello C. Now this way you can also use the macros. Let us go for another program. Find the output of the code. Hash include stdio.h, then int main and return 0. Here let us define a macro. As defined, a is suppose 5. Okay. Now let us write down conditional compilation. Let us use it in this program. Hash if defined a, if it is defined a, then it will return true. Then what you are going to do? You want to define the value of b now as 10. So and end if. So we have defined a macro, we have checked whether it is defined or not, and then we have written the closing tag. Then print the value of printf. Print the value of a and b. A comma b here. So you have to understand over here, a and b are the 2 macros. The value of a is 5, the value of b is 10, but we have just done a conditional compilation that whether the macro is defined or not for a. So here the macro is defined, so it returns true. Now let us save and run the program. So what should be the output of this code? So the output of the code is 5 and 10 because a is defined, which returns true, and b is also defined, so which is 10, and the print statement will give you the output of a, b as 5 and 10. Now let us go for another example. Find the output. Has defined a as 5 again, and let us write hash if def a. if it is defined, then write down the main function. Inside the main function, let us define the value of b as 10 and write as endif. Let us check the value of AB again. So percentile D twice, comma A, comma B, and return 0. Now, what will be the output? So you can see here A is defined as 5. Then we are checking the condition outside. If defined A, so it returns true. Then again we are defining the value of B. Then we are checking the output. So obviously the program should give you the value 5 and 10 again. So Control S, save the program and then run it. So you can see the output is as 5 and 10. So you can write down the hash if defined inside the function or outside, because it just checks whether the macro is defined or not. It always returns true. If it is defined, it returns true. So here you are getting a small warning that we have not written hash include stdio. Due to that, you are getting this warning that implicit declaration of built-in function Printf. Okay, no issues. So if you want, you can write down the hash include statement here. Hash include stdio.h. And if you will compile it again, then the warning will go. Right. Now let us go for the next program. Find the output. Hash include stdio.h. This is the header file you have included. Now let us define a parameterized macro f of g, v. G, v. Two parameters it takes, which is nothing but g token pasting with v we have done. Now let us write our main function where we want to print the value of, we want to use this parameterized macro. So percentile D, comma, use the parameterized macro f of 12, 100. For example, we have given these values. Okay. So once it is pasted or these two values are combined, then what will be the output? So token pasting operator normally combines both the values and it prepares a single value. So it is, let us write as 12. Okay, we have saved this program and you should get the output as 12100. So let us check it. Yes. So both the values are pasted together. So it is giving you a combined string. So we are getting 12100. Now let us go for the next program. Find the output. Hash include stdio.h, int main and return 0. Now let us define a macro over here. Again a parameterized macro. Has defined man is a macro which takes two arguments or parameters x and y, and we are writing a conditional operator over here. So x, if it is greater than y, then if it is true, then you have to take the value of x, otherwise you have to take the value of y. If the condition is true, then x value is returned. If the condition is false, then y value is returned. So put a semicolon. Now let us write down the main function. So here let us declare the variable int I is equal to 10, comma j is equal to 5, comma k is equal to 0. Now use the macro k is equal to man followed by plus plus I, comma j, plus plus. Okay, that means first time we are using the macro with x value as 11, comma, j value, j plus plus post increment is there. So initial value of j is 5. We are using it like this. Okay. Then after that, what will happen to I value? I is 11. So I is 11, which is greater than 5, which is true. So x value is returned. So that x value we have to evaluate like this. K is equal to our x value, which is nothing but plus plus 11, which will give you the value 12. So x value becomes 12. And we have to print the value of I, j and k. So if you will see percentile d, 3 times you have written, then followed by I, comma, j, comma, k. Now, return 0. Okay, already written. Let us remove this. Okay. Let us save the program and check it. Now, if you run this program, the value of I you will get as 12, value of j you will get as 6, and value of k, the written value is nothing but the value of I only, which is nothing but 12. So 12, 6 and 12 is the correct output for this code. So hope it is understood. Now let us go for another code. Find the output, hash include stdio.h, int main and return 0. Let us define a macro. Has defined, the name of the macro is print. You want to print one integer, print int, and which is nothing but a printf statement. Int is equal to percentile d, comma, integer. So you have written a printf statement in the macro, okay, which takes only one parameter. Now let us write our main program. Let's declare some variables. Int x is equal to 2, y is equal to 3, comma, z is equal to 4. And call the macro thrice, once with x value, then once with y value, and once with z value. Okay. Now what will be the output? So with x value it will print 2. Yes, it will print here 2. With y value it will print here int is equal to 3. Similarly with z value it will print int is equal to 4. Let us check it. Now let us save the program as 14.c. Okay. Now let us run it. Yes, you can see here first time int is equal to 2, then 3 and then 4. So, okay, this is the correct output for this code. Now let us move on to our next code. Now we want to do swapping or swap two numbers using macros. Okay, so write down hash include stdio.h. Let us define a parameterized macro. Name of the macro is swap, which takes two arguments a and b, and let us define it. So for swapping the two numbers, let us take one integer variable int t, followed by t is equal to a, comma, a is equal to b, comma, b equal to t. So this is the logic for swapping we have written over here. So whenever you will call the swap macro, these statements will be replaced. T is equal to A is equal to B, and B is equal to T. Okay. Now let us write down our main program. Int main and return 0. Now here let us declare two variables, A is equal to 10, B is equal to 20. Now use the macro. Swap is the name of the macro, A, B. So before calling the macro or using the macro, let us print the value of AB once. Okay. So let us write before swap, A is equal to percentile D, comma, B is equal to percentile D, comma, A, comma, B. Now let us copy this and use it for after swap. So let us write this as after swap. Okay. So whenever swap is called over here, it will be replaced by one temporary variable is declared int T over here. Then using the temporary variable, A and B values are swapped. Let us save it and let us check whether swapping is taking place or not. So you can see over here, before swap A was 10, B was 20. After swap A is 20 and B is equal to 10. So using a macro also, you can do swapping program. So you can paste the output over here. Now let us go for the next program. Find the output. Hash include stdio.h, int main and return 0. Okay. Now let us declare one parameterized macro. So hash define max is the name of the macro, which takes two parameters A and B. And we have defined as if A is greater than B, we have used a conditional operator over here or ternary operator. If A is greater than B, then return the value of A as the maximum value. Otherwise, return the value of B as the maximum value. Now, let us use this macro in our program. So, define an integer variable x and x is equal to, use the macro max with the values 3 plus 2, comma 2 plus 7. Okay, and print the value of x, which is nothing but the output of this code. So x is equal to percentile D, comma x value. Okay, it's a simple macro or a parameterized macro where one conditional statement is written. If A is greater than B, then A value should be returned as maximum value. Otherwise, B value should be returned. So save this program and run it. So you can see here the value of A is 3 plus 2 and value of B is 2 plus 7. So what is the output? 3 plus 2 is nothing but 5 and 2 plus 7 is 9. So 5 is greater than 9. So no. So B value is returned, which is nothing but 9. So the output becomes 9 over here. So this is very simple. So it will combine or add the value and then use it as the parameter A and B. Now, after this, let us understand the next question. Find the output. Hash include stdio.h, int main and return 0. First of all, define a macro over here. So hash define suppose minimum is the macro over here, and we want to find out the minimum of x and y. So let us define in the similar manner. If x is less than y, okay, then we are writing a conditional operator here, either x, otherwise y. Okay. Now coming to our main function, let us take some variables. X is equal to 3, comma, y is equal to 4, comma, z. Z is equal to mean of x plus y by 2, comma, y minus 1. Okay. So mean should be replaced over here, and if z is greater than 0, if you are getting the output of z as greater than 0, then you have to print the value of z. That's all. Okay. So there is a condition based on again the return value of z. If it is greater than 0, then you have to return. So here the parameters are x and y. So what is x? X is nothing but x plus y by 2. So x plus y by 2 is how much? So let us first save it. Okay. Now compile it first. So you are getting the answer as 3. So you can check it. So x plus y by 2 is nothing but 3 plus 4 by 2. So how it is evaluated? 3 plus 4 by 2. Division is having higher priority. 4 by 2 is 2. So 3 plus 2 is 5. So 5, this is equal to 5, comma, y minus 1. Y minus 1 is 4 minus 1 is 3. So 5 less than 3. 5 is less than 3. It is false. So if it is false, y value is returned. What is the y value? Y value is nothing but your 3. So z value becomes 3 over here. Okay, output is become 3. So 3 is greater than 0? Yes. So print the value of z. So we are getting here 3. So hope it is understood. Let us run it and see it again. So you can see that the output is coming as 3. Now let us move to the next question. Find the output. Hash include stdio.h, int main, and return 0. Now define a macro. As defined, name of the macro is mess and its value is junk. Okay. Now in your program, simply write printf mess. So what will be the output? It's very simple. So let us save it and run it. So mess should be replaced by junk. So what will be the output? Can you see over here? You got only mess, not junk. Okay, because whenever you have written the value of mess in double quotes, now for the printf function, it is just a string to be printed on the screen. It is just a string to be printed on the screen. That's why the mess macro is not replaced with its value junk. So due to that reason, you will get only mess, not junk in this question. So this is very interesting, and this small trick you have to understand. Okay. Now suppose you want to print junk also. So what you have to do? Let us declare. So here, if you will write, instead of this, if you will write %s, comma, mess, then what will be the output? Let us check it. Yes. So junk is undeclared, it is saying. Okay. Now in expansion of the macro mess, junk is undeclared because. So let us change this to, you have to do the replacement first and then you have to go for, yes, it has to be a string, then only you will get the output properly. Yes. Now, the mess is a string over here, and to see the output, it should be replaced with junk, and if you want to see the output as junk, then you have to write it down as a string, and the string we are printing. So, this is the output of this program. Now, let us go for one more program. Find the output. And in this, let us do a program for calculating simple interest. How to do this? Hash include stdio.h. Now do this program with the help of a macro and replace the macro values to find the simple interest. So let us define a macro as defined. SI is the simple interest, name of the macro, which takes three parameters P, N and R. P is the principal amount, N is the number of years and R is the rate of interest. So let us declare here float SI for computing simple interest, and SI is equal to P into N into R divided by 100. So let us put PNR into bracket divided by 100. So the formula for computing the simple interest we have written over here, and then simply we need to use this macro in our program. Return 0. Now let us declare a float variable P is equal to 2500, comma R is equal to 3.5. Rate of interest is 3.5. P is the principal amount, which is nothing but 2500. R is 3.5. And number of years is N is equal to 3. Call SI with the values, with the arguments P, N and R. Similarly, once again, call the macro SI with the values 1500, 2, 2.5. So instead of taking the arguments as variables, we have directly taken the values. Now, what will be the output of this macros? Okay. And so we have written return 0. Let us save it first. And run this. So here we have written simple interest here. Float is a simple in expansion of macro. So let us rectify the errors. So here what you have to do, we have to write down the printf statement, printf percentile point to f, a point, let us write point to f, comma si. Okay, now let us run it. Otherwise, we can, yes, this is not small si, this is capital Si. Let us set it. Yes. So we will let us remove this variable from here and declare a variable Si over here. So let us write Si is equal to this much. Here the print statement also will remove and we'll write it down here. Okay. This is also not required. Yes. Now the output is correct. Okay. Let us do the formatting little bit. So here put it /n, both the places. Okay. Now SI is the macro with 3 arguments, which is defined as PNR by 100. So PNR values, whenever you are passing, it is replacing with P into N into R by 100. It is computing the simple interest first time, and for 2,500 as the principal amount, rate of interest 3.5, and the number of terms is 3 years. It is giving you the output as 262.50 with the simple interest. Second time, we have reduced the principal amount to 1,500. So number of terms is 2 years and rate of interest is 2.5. So the interest, simple interest is computed as 75 rupees. So this is the output of this code. Now let us move on to the next question. Find the output. Hash include stdio.h, int main, and return 0. Now here let us declare one integer variable I if hash if a. If a is defined, a is a macro, but we have not defined that macro over here. Then we are writing the printf statement, printf enter any number. Okay, enter any number, and scanf %d, comma, the value of I we are going to read. Right? Now, if not defined, hash elif b, then we want to write printf, suppose the number is odd, suppose. Okay, we have written one statement called the number is odd and return 0. Let us save this and run this program. So you can see over here in this program we have not defined A and we have not defined B. Then what will be the output? So you can see here we have written hash if and hash elif, but we have not written the closing tag. Okay, so unterminated elif it is showing. Unterminated elif. So let us rectify the errors first. So if you want to use, you can write hash else and remove here B, followed by, if you want, you have to write the closing tag end if. Now let us compile and check again. Yes, you can see here the macro A is not defined. That's why it is directly going to the else part, and the message the number is odd it is displaying. Now let us define a macro over here and check it. So hash define A as some tag. Now save it and run it. So now it is the hash if the condition is true. So if condition is true, it is asking me to enter any number. Suppose the number is 20. So it is reading the value of I as 20. So if you want to display that number, you can display it. Printf %id I is equal to %id, comma I value. If you want to display, you can also display like this. So let us run it. So here A is defined as a macro, so the condition is true. So let us define and let us give a number 100 and I is equal to 100 is displayed. So in this way, you can do a number of programs using the preprocessor directives. In this video, we have learned a number of programs using preprocessor directives, and we have executed a number of programs related to the macros, simple and parameterized macros, followed by conditional compilation, your file inclusion, and so on. Thank you so much.
like, share and subscribe. Hit the bell icon for more updates.